So today we're going to be talking about quadrilaterals and whether they are parallelograms or not. So we need to know a couple things about parallelograms. So a parallelogram will always have opposite sides being congruent, opposite angles being congruent, and opposite side lengths. So these angles will be congruent as well, and then this side and this side will be congruent. Another thing that is always true about parallelograms, it's kind of in the name, is that opposite sides are parallel. So if those things are true, then we have a parallelogram. So we really only need to have one of those qualities. Oops. And we will be able to prove that the quadrilateral is a parallelogram. So in this case, this is a parallelogram because opposite angles are congruent. So that's how we know that example 1 is in fact a parallelogram. So in example 2, we can see right away that these two angles are congruent to each other. So again, the answer would be yes. So you could write yes if you want. Because opposite angles are congruent. In example 3, we got to determine whether this is a parallelogram or not. Well, I don't know if the opposite sides are parallel, so I can't say that. I don't know if these angles over here are congruent or these angles are congruent. I don't know that. I don't know if these side lengths are congruent. All I know is that when two lines cross each other, they're vertical angles. That's true. And these are also congruent. But it doesn't tell me anything about these angles. Doesn't tell me anything about the side lengths at all or whether they're parallel. So we can't say if this is a parallelogram or not. So there's not enough info. So we got to have some info about these angles or the side lengths or whether the sides are parallel or not. If we don't have any of those three things, we can't say whether it's a parallelogram or not. In example 4, determine whether the quadrilateral is a parallelogram. So in this case, we know that this side and this side is congruent, and also to this side. So notice that we got a little transversal here. So I know that these two angles are congruent to each other because they are alternate interior angles. I know that these two angles are congruent to each other because they're also alternate interior angles. So right away I know that these two angles, so if this has one arc, this has one arc, and then this has two, and this has two, this whole angle is going to be the same as this whole angle. Probably drawn too many arcs here, but so we got opposite angles are congruent. So the answer is yes. Opposite angles are congruent. I should have wrote the little symbol instead of writing out the word. We also know that the opposite sides are congruent, at least these two. On the next page, so now we can prove a quadrilateral is a parallelogram. So let's see if we can work backwards to figure out what maybe the missing values are. So again, if opposite angles are congruent, then we know it's a parallelogram. So what value of x would make this shape a parallelogram? Well, if I want these opposite angles to be congruent, then I could just say, well, x has to equal 70. One more thing that I haven't mentioned yet that we also can use, and we're going to have to use on the next example. Consecutive sides, or sides that are adjacent, so consecutive sides, not opposite sides, consecutive sides, those have to be supplementary. So if I added x plus 110, that would have to equal 180 to make this a parallelogram. So subtract 110 on both sides, So x equals 70. So notice we get the same answer no matter which way we do it. But that's two different ways we can figure out if it's a parallelogram. In example 6, this time we only know the consecutive angles are x and 2x. So like I just mentioned, if they're consecutive angles, in fact we already know that these two sides are parallel, so that's a good first step. But x plus 2x would have to equal 180 because those two angles are consecutive and they have to be supplementary. So combine like terms, I got 1x and then 2x's, so that's 3x. Divide by 3, so x equals 60. So if x is 60, then that would be a parallelogram. And then example 7, what value of x will make the polygon a parallelogram? So these two angles that they give us information about are on the opposite side of the shape. So what do we know has to be true about opposite angles for the shape to be a parallelogram? Hopefully you say they have to be congruent. So 17x plus 5 would have to equal 107. Subtract subtract 5 on each side. So 17x is going to equal 102 and divide by 17 on both sides. So x would have to equal 6. And then just as a little quiz, what value of x will make the polygon a parallelogram? So go ahead and figure that out.